I know there's a lot of theories out there at this point, and there's still a lot to be done in brain research and other research. Can you explain why you believe EMDR works?
Well, we aren't sure exactly how EMDR works, and there are several leading models to explain the well-established effectiveness of EMDR. So the first thing is to be clear that EMDR is a well-established approach to psychotherapy and has been shown to be effective for post-traumatic stress disorder, acute stress disorder, and for specific phobias. And there's quite a bit of emerging evidence for other conditions as well. The two primary models that are given the widest attention for how EMDR works, the first is the REM, orienting response hypothesis, and the second is the working memory hypothesis. The REM, rapid eye movement or orienting response hypothesis, assumes that the system in the brain for the orienting response is behind the effectiveness of EMDR. And the REM hypothesis, which explains how memory is reorganized during REM sleep. These two actually fit together. So as most mental health professionals are aware, all mammals have REM sleep, rapid eye movement, dreaming sleep, and deep sleep phases. And in the REM phase of sleep, memory is pruned. Parts of memory are thrown away. Without this, we would be left with a flood of images and feelings and physiological responses to mildly and severely distressing life experiences. During REM sleep, memory is digested and the unimportant aspects of memory are discarded, taking away the emotional vividness, taking away the sensory vividness of memories, and leaving us with the gist of these life experiences, the most important parts and the parts that we can learn from. Something similar seems to happen during EMDR, during the eye movements with EMDR. The unimportant parts of memory, the vividness of the feelings, the vividness of the sensory impressions, become weakened and fade in a way very similar to what happens during REM sleep. And partially this may be because of what's called the orienting response, which was developed by Sokolov, a contemporary of Pavlov, who described a multi-phase process for how mammals respond to novel stimuli in the environment. When there's a novel stimulus in the environment, say a noise in the bush, and there's a deer out grazing, acting under instinctual behavior, it hears this noise and it orients towards it. It turns its head, its ears swivel, its eyes scan the environment, its nostrils sniff the air, trying to determine if it's a threat or not. And one of three things happens at that point. The first is that with orientation, there's this spike of arousal, and then during this appraisal phase that comes right afterwards, the animal checks a database stored in the amygdala, the flight-fight center of the brain, for all previous threat cues. And it compares the incoming sensory inputs against what's stored in the emotional part of the brain. And if it's a predator that's emerging from the bushes, the deer sees it in a 25th of a second. It's fleeing. If it's a big male deer with antlers and the doe is in rut, then she sniffs the air and she starts maybe prancing off towards the male, something good. But if it's just the wind blowing the bushes, it's determined to be neutral, uninteresting, and the arousal goes down. Well, this is what happens during eye movements with EMDR. You have an orienting response. There's a brief spike up as the eye movements begin, and then as the amygdala looks out through the eyes, it's kind of in this paradoxical situation because the therapist has activated all the trauma cues active in the imagery in the brain, in the same parts of the brain where you see current imagery. When you bring up old memories that are traumatic, the same parts of the brain are active as during current sensory perception. But the amygdala now is looking at the little lights or the hand of the therapist going back and forth and sees something boring. It's not a threat, it's not exciting either. And so arousal goes down. So the orienting response model says that the de-arousal is a kind of a compelled relaxation response. That's what David Wilson called it. Part of the normal investigatory or orienting response process when the emotional parts of the brain perceive boring sensory stimuli. So what happens during REM is that emotionally intense material moves from the right hemisphere, stored in vivid sensory form, to the left through a process organized primarily by dopamine. These two things seem to go together. The orienting response, the REM system in the brain being activated, information becomes decreasingly vivid, decreasingly intense, and moves from the right hemisphere into a narrative form in the left hemisphere. So that's the first hypothesis. That's the REM orienting response hypothesis. There's not a lot of research behind that, but there are some studies that support it. For example, the Kuiken study, Kuiken, Baer, Miles, and Stern, I believe, did a study showing that with eye movements, we become more creative. We find more creative ideas, and they had a very novel research protocol for demonstrating that, showing that we make new associations more easily when we're making eye movements. The hypothesis with the most research support for it is the working memory hypothesis. And this is actively being investigated by a group of researchers in the Netherlands, and they've done a large number of studies that support this, showing that both eye movements and auditory tones and the kinesthetic stimulation that we use are capable of disrupting working memory. There are several parts of working memory, but let's stay with the visual working memory for just a moment. If you see information written down, say a phone number you want to memorize, you temporarily hold that information in your short-term working visual spatial template of working memory. If you then move your eyes, it will disrupt the image. You won't be able to hold on to it. Working memory hypothesis researchers have demonstrated through their studies that for most disturbing memories, the eye movements are dramatically more efficient at disrupting working memory than the auditory tones or kinesthetic stimulation, because they disrupt the visual spatial template of short-term working memory. However, some clients are suffering more from difficulties with sounds of disturbing memories. And in some cases, the auditory tones may be better for some people, but certainly we can use them if people cannot tolerate the eye movements. So the working memory hypothesis has shown that different forms of distraction work almost as well as the bilateral eye movements that we use. Almost any visual distraction will work. The eye movements are just a little bit more efficient than some others. So those are the two leading hypotheses. Now, there are others slightly more esoteric, having to do with the role of the thalamus in the brain and a 40 hertz binding frequency that's put out by the thalamus under certain conditions, and the eye movements seem to enhance the ability of the thalamus to put out that 40 hertz signal. One of the factors that allows consciousness to occur, that is, for a person to be aware of what's going on in their brain, is different regions of the brain need to be simultaneously in communication with each other. As you know, during states of dissociation, different parts of the brain are active, but they're not in communication with each other, and so there's a fragmented experience. The 40 hertz signal that's put out by the thalamus helps to coordinate disparate regions of the brain so that they come into a relationship with each other and help to create a cohesive experience of consciousness with all the different facets of sensory perception and memory and cognitive capability. So the eye movements that we use in EMDR seem to enhance the ability of the thalamus to coordinate activity from disparate regions of the brain and allow consciousness to come into play. Another factor that's a hypothesis for what allows EMDR to work is the process of mindfulness. Some people who have studied meditation have joked that EMDR is like mindfulness meditation on steroids. And certainly there's evidence from some of the brain studies that have been done that prefrontal activation, this part of the brain, the prefrontal orbital cortex, where executive function resides, is activated more strongly following EMDR sessions. It brings the prefrontal system back online. And the prefrontal system is one of the things that allows the brain to regulate the level of activation in the emotional brain, in the mammalian brain, in the limbic system. And so enhancing mindfulness is one of the factors that EMDR seems to do. Certainly the metaphors that we use when we do EMDR are intended to enhance mindfulness. We use the metaphor of being on a train and just noticing what's happening, the need not to have to verbalize, but to simply notice things silently during brief intervals of eye movements enhances the client's ability to mindfully attend to their experience without having to engage in narrative, without disrupting a continuous process of just noticing. And the eye movements seem to enhance the brain's ability to go into that state of mindful noticing without judging, which is very different than what happens during prolonged exposure, where people often go into very prolonged, intense emotional experiences and are sort of stuck there for an hour or longer. During EMDR, the experience of intense emotional reprocessing is typically very brief because mindfulness comes to play, the de-arousal process comes into play, working memory comes into play, and things change very quickly. So those are 4 of the leading hypotheses for how EMDR works. There's probably some others that I could talk about. I'll just mention a 5th for fun, the cerebellum. Cerebellum is the part of the brain in the back that, well, it used to be thought of as predominantly involved with sensory motor coordination. It does a lot of other things. One of the other things that the cerebellum does is it helps to regulate our emotional life. And a healthy cerebellum is able to help downregulate activity in the amygdala. People who were raised with emotional neglect and abuse, you will often hear that they will report that when they become agitated, they rock, because they can't do this internally in the cerebellum. The 2 halves of the cerebellum are not properly connected. The cerebellum vermi that connects the left and the right cerebellum is incompletely developed. And so in EMDR, when you do bilateral eye movements, you get activity going on both sides of the cerebellum. It enhances the activity in the cerebellum and helps the cerebellum to downregulate excessive activation in the amygdala. Left eye movements are therefore more effective because it's an active muscular movement of the eyes, whereas passive listening to auditory tones or kinesthetic stimulation don't activate left-right cerebellum nearly as strongly. So those are 5 of the possible hypotheses for what's going on. None of them have been demonstrated conclusively, but there's new research that's being done where you can do simultaneous EEG and MEG studies during EMDR. In the past, we weren't able to actually monitor the brain during eye movements because it produces a lot of artifacts on EEG. But there's new technologies that are going to allow us to monitor the brain in real time during EMDR sessions. Previously, we've seen changes pre and post. We've seen what can happen with a SPECT image before EMDR versus a SPECT image after. We can see how the overactivation of the right hemisphere is moderated. The underactivation of the left hemisphere is brought up as the information moves from the right to the left side. Increased activation in the prefrontal regions, decreased excessive activation in the anterior cingulate. But we've never been able to watch the brain in real time during EMDR. That's just starting to happen. So I think these next few years we're going to see a lot more brain imaging studies and other types of brain studies that will demonstrate conclusively exactly what's happening during EMDR. But you know, we don't know how other therapies work yet either.
Right.
So we have some good hypotheses and the research is coming.